Welcome to the Flexim training series. This series of videos will offer you technical training on how to use different products and perform various functions with Flexim's line of clamp-on ultrasonic flow meters. Today we'll be watching video number 3, which will teach you how to program a single-channel, permanently installed BTU meter. Other videos you might be interested in watching are numbers 4, 6, 8, 9, or 10. These videos will show you how to install transducers on a pipe, how to terminate cabling on a permanent meter, how to install our Permalock tracks, how to install our temperature cable junction boxes, and lastly, how to install our transducer cable junction boxes. For more advanced features, you can also watch video number 7 on how to download information from a meter into a PC, or video number 12, which covers how to retrieve diagnostic information from the meter while you're measuring. But before we begin, I'd like to talk to you a little bit about what we're going to be covering in some more detail. We're going to start by briefly talking about temperature probe installation, and then we'll see how our keypad is laid out and how to navigate through our menu system. Next, we'll talk about how to tell the meter about the pipe and fluid we're measuring, and then we're going to go into some detail about how to configure process inputs and link temperatures, and how to set up outputs such as a 4 to 20 or a relay. After that, we'll go through the process of actually starting a measurement, and lastly, we'll talk about how to tell the meter what you'd like to see on the screen while you're measuring, and if you'd like to change that or other default values. We call this output options. This is the order you'll want to use when setting up a meter as well.
The first thing we're going to talk about today is our temperature probes. We highly recommend insulating over the temperature transducers very well to ensure that you're measuring the fluid temperature accurately. As far as installing them, our temperature probes have one flat side, and this is secured against the pipe with our included mounting hardware. Let's turn our attention now to the keypad of the 7X07 BTU meter. We have a clear button, an escape or break button, and an enter key on the right sides of the keypad. The clear button allows you to clear values you've entered incorrectly. The break button allows you to escape back to the main menu while navigating anywhere within the menu system. And of course, we use the enter key to confirm all of our choices and to navigate deeper into each menu. Next, we have 10 number keys, 0 through 9. 4 of these keys, the 4, 6, 2, and 8 keys, also perform double duty as arrow or navigation keys. Whenever we see a left and right arrow on the LCD, like on the main screen, we only have the option of scrolling left and right using the 4 and 6 respectively, or hitting enter or break. Hitting any other key will result in an error or beep. We can use the enter and break keys just as you would use them on a cell phone or any electronic device. Enter confirms items or goes deeper into the menu structure, and break or escape returns you to the main menu. You'll also commonly see up and down arrows on the screen. When we see these, we must use the 8 and 2 keys to scroll up or down. One thing to note here, all menus within the 7X07 scroll. This means that if we start going up or down, or even left or right, anywhere in the menus, we'll eventually get back to where we started. The up and down keys are mostly used for selecting from lists such as materials, fluids, liners, and the like. And when you get the appropriate item, hit enter and select it. Now that we talked about how to use the meter, we should look at how to actually program the meter to take a measurement. The first menu we should look at when setting up a new measurement is the parameters menu. This is where we'll input all the information we have about the pipe, fluid, and liner if it's present. Start by scrolling to PAR for parameters and hit enter. Next, we can choose which channel to adjust parameters for if we're working with a 2-channel meter. We have options of setting channels A, B, Y, or Z. A and B are the physical channels in the meter, and channel Y and Z are calculated channels, so we can either average or sum the output from the physical channels A and B. For now, let's configure just the A channel, since most of you are probably interested in single channel measurement. Now we're going to select channel A by scrolling up and down, then hit enter. Now we need to enter the outer diameter of our pipe. Be careful here to enter the actual outer diameter and not the nominal dimension. If we're trying to measure on a 6-inch pipe, for example, our outer diameter is actually 6.625 inches, not 6 inches. On a 12-inch pipe, our outer diameter is actually 12.75 inches and not 12 inches. So the key here and everywhere in our menu system is to put in the actual dimensions and not the nominal ones. Let's enter the OD now for a 12-inch pipe, 12.75, and hit enter. Now we need to enter the actual wall thickness of our pipe. From a pipe chart, we see that a Schedule 40 carbon steel pipe has an actual wall thickness of 0.406 inches. So we enter 0.406 and hit enter. The other option we have here is to use our wall thickness gauge to get a more accurate measurement. We highly recommend this option if it's available. Because of the way all our ultrasonic meters work, the more accurate this number is, the more accurate your final measurement results will be. Now we're prompted to enter the pipe material. We have many different materials available in our material database to choose from. So chances are, no matter what you're trying to measure on, you'll see it here. As an option, if for some reason you don't see what you're looking for, we can always add items to this menu if you give us all the variables for your particular material. For now though, let's assume we're taking a measurement on a standard carbon steel line. I'm going to choose carbon steel from my list of materials and hit enter. Our next option is to choose if we have a lining present. For most measurements, this is a no. So we'll choose that and hit enter. Also notice that through all of our menus, whatever was chosen last time is the default value. Since last time I did a measurement, I chose I had no lining present. So the default value is still no. Roughness is a measurement of the microscopic imperfections in the surface of a material, and our database has average values for each material by default. We can simply leave the default value alone and hit enter. We're now asked which medium we're measuring. This is the liquid in your pipe. Choose the liquid we want to measure from our extensive list and hit enter. For this example, we can choose water, but we also have many other liquids such as high and low API crude, beer, mobile therm, and many more. Also, if you don't see a medium listed that you'd like to measure, contact a Flexim representative to find out how we can install new mediums into your meter for you, either before or after your purchase. Now we're prompted to enter the medium temperature. Here we need to put in an approximate value for the temperature of your fluid. This is only used to help the meter figure out where to tell you to install the transducers. Don't worry if you don't have the exact temperature. You can even put your hand on the pipe and make a guess if you don't know. And this is usually more than sufficient to get a good placement distance for your transducers. Of course, Flexim can measure pipes up to 750 degrees Fahrenheit. Don't put your hand on those. The last option under the parameters section we need to enter is the amount of transducer extension cable we're using. If our transducers are connected directly to the meter without any extra cable, we enter 0. If we have used the junction box, we put in the length of cable from the junction box and hit enter. Hitting enter this last time has brought you back to the main menu. And now we're ready to tell the meter about any inputs we like to use. The process inputs section of special functions is found by first going to the special functions menu and hitting enter, then scrolling down until we see process inputs. Hit enter to go into the process inputs. In here we have 3 options, and we'll need to make sure they're all set correctly. The first is PT100, PT1000. This is where we choose which types of RTDs we'll be using. To set this, hit enter and scroll left or right to the correct type of RTD and hit enter. Going up one option from PT100, we have link temperature. Hitting enter here gives us the option of the type of system to set up. We can either use a heating system or chilling system, such as for chilled water. Let's choose chill for now and hit enter. Now we need to choose where we did or are going to mount our transducers, either on the supply line or return line. We generally recommend installing on the supply line, and of course we hit enter to continue. We now have a prompt for absolute or sign. This allows us to show a negative value for our energy rate if our temperature RTDs are mounted backwards. Most people generally leave this on absolute. Next, we get to choose how to measure our supply and return temperatures. Assuming we're using RTDs on both supply and return, scroll to input T1 for supply, hit enter, and then scroll to input T2 for return, and hit enter to confirm. We can also simply skip T3 and T4, leaving them at no measuring, and hitting enter on each to confirm them. Now we can hit break to escape from this menu since we've done everything we need to here. The process output section of special functions is found by first going to the special functions menu and hitting enter. Then scrolling down until we see process outputs. Hit enter to go into the process outputs menu. Scrolling up and down here, we have several options depending on how your meter was configured or ordered. We have I1 and I2 for 4 to 20 outputs. We also have B1, B2, and sometimes F1 for binary and frequency outputs respectively. For our binary outputs, we can set limits for alarm values or use them as pulse output to your PLC. But for now, we're going to assume you're using a 4 to 20 signal, and we'll choose I1 and hit enter. Choose the channel you'd like to set the output for. Channel A for us, and hit enter. Now we can scroll up and down for several options, the most common of which is measuring value. This allows us to output flow rate, heat flow, fluid velocity, our totalizer, or even sound speed. Next, we choose actual measure. This will let us put out as a 4 to 20 whatever we set as our main output for the LCD. This is the option that generally makes the most sense for our customers. Now we can choose the type of current output to use, 0 to 20, 4 to 20, or other values. Of course, we're going to choose 4 to 20 and hit enter. This brings us to the error value option. This is the value that you'll see from the meter if the pipe becomes empty or we get lots of entrained gas or solids. We can choose from holding the last value until we're able to read again, 0, 4, or 20 milliamp, or some other value. We found that the best choice here is to generally use other value and select 3.5 milliamps. This way, if you ever see 3.5 milliamps on the PLC, you know that your pipe isn't full or that you have something undesirable happening in your pipe. The meter now tells us where to physically plug in our 4 to 20 wires to the meter. For I1, this is always on P1 plus and P1 minus. Hitting enter now allows us to test the signal if we'd like. And now choosing not to test again, we're back to the main process outputs menu. Hitting break has brought us back to the main screen, and now ready to begin a measurement with our meter. I'm going to start by navigating to the measurement menu. This is labeled as MEA on our screen. Hit enter to go into the menu. The first option we have is the channel we want to begin measuring on. With our meter, we can actually enable and disable the channels we want to use individually by navigating to the channel using the left and right keys, and then using the up and down arrows to place or remove a check mark from each channel. Since we're only using channel A, we'll make sure that channel A is enabled and hit enter. The next screen, we're presented with a measure point number. This option allows us to give either a numeric or alphanumeric name to each measurement depending on which option you've selected in the Special Functions menu. I've selected numeric names, so I'll call this measure point number 1 and hit enter. Now, we're given a recommendation of the number of sound paths. Sound paths are the number of times the ultrasonic wave traverses the fluid. If the beam goes straight through the fluid once, we call this direct, or one sound path, and we must mount our transducers on opposite sides of the pipe. We call this direct mounting. The more preferable way to mount our transducers is in what we call reflect mode, or two sound paths. In this mounting system, the sound goes through the fluid twice, bouncing off the opposite wall of the pipe once, and we mount our transducers on the same side of the pipe, one several inches downstream from the other. This has several benefits, not the least of which is that it's physically much easier to get proper placement and access to the transducers like this. You can watch video number 4 for more information on how to install our transducers on a pipe. For now, let's choose two sound paths or reflect mode and hit enter. This brings us to the transducer distance screen. Now that we told the meter how many sound paths to use, it's recommending the optimal distance to place our transducers apart on the pipe. And remember, since this is reflect mode, we'll have both transducers on the same side of the pipe. This makes it very easy to measure the distance the meter is recommending. We simply measure from the face of one transducer to the face of the other. So we need to actually install our transducers at the closest distance we can easily measure on a tape measure near what our meter is recommending. We try to stay within a plus or minus quarter of an inch of the meter's recommended distance, and then we will tell the meter the actual distance we place the transducers at. So now that we know where the meter wants us to put the transducers, we can hit enter. This brings us to the signal quality screen. Here is where we actually mount our transducers on the pipe at a distance as close to the recommended distance and still easily found on a tape measure, as I've just described. Now, since we've already mounted our transducers, we'll need 2.5 to 3 bars of signal and a green light on the keypad. We have a green light, meaning we could start measuring, and 6 bars or 60% signal quality. This is a great signal. Let's hit enter now that we've verified we have a good signal and are ready to measure. Now we get to tell the meter exactly how far apart we actually put our transducers. Input the actual distance we placed the transducers at, and hit enter. Lastly, we have a prompt for the temperatures T1 and T2, and we can verify that they're correct. If we simply hit enter one last time, we're measuring. And now we're done. We're reading thermal energy on our line. You can play with the 9, 3, and enter keys to check diagnostics on your measurement. For full details of how to do this, please watch video number 12. Lastly, we're going to look at the output options menu. You'll want to access the output options menu if you need to change any of the default values. Let's begin by scrolling over to the output options section labeled out on your main screen and hit enter. The first thing we have here is again a choice of the channels we'd like to set up output options for. Just like in parameters, we have options of setting channels A, B, Y, or Z. For now, let's configure just the A channel since most of you are probably interested in single point measurement. The next option we have is the physical quantity we want to measure. We can choose between thermal energy, volume flow, flow velocity, mass flow, or sound speed. So let's choose thermal energy to output the rate of energy usage for our system to the screen for channel A, and hit enter to confirm. Now we need to pick the unit we like to see. We could choose tons or BTU. For now though, let's choose BTU as our unit and hit enter to confirm. Dampening is the amount of averaging the meter will perform while measuring. For example, we generally use 30 seconds of dampening for our measurements. This means that the meter will average 30 seconds of flow data, and every subsequent second the meter will take in 1 additional second of data and throw out data from 31 seconds previous. This way we're always looking at the average flow rate over the last 30 seconds. Of course, if you like to average over a shorter or longer period of time, this is perfectly fine as well. For now though, let's use 30 seconds. And since this is already in the meter, we can simply hit enter to confirm. This next option is very important. We have several different ways of taking information out of the meter. We can simply look at the display, we could take a 4 to 20 milliamp signal out to a PLC, or we could store data in the meter itself in our 100,000 point internal data logger and retrieve the information to view on a computer at a later time. This is the purpose of store measured values. We generally recommend to keep this turned on since there is absolutely no downside in doing so. However, if for whatever reason you would choose to turn this off, we could simply scroll left over to off to disable it. For now though, let's leave this as the default of on and hit enter. Serial output allows us to connect directly to PC while taking measurements and display or download that information in real time. If we physically have a serial cable between the computer and flow meter, we could choose yes. In our case, we're not using this. Storage rate allows us to choose how often to store a data point into our internal data logger. Once a minute is fine for a measurement over 20 or 30 minutes. Once an hour is fine for a measurement over a day or two. Using the data logger set to once per second, we have just over 24 hours of storage capacity, or at once per minute, we have about 70 days of storage capacity. However, you could set this value to record as infrequently or as often as you'd like. For now, let's set this to once per minute and hit enter to confirm. Now, we're prompted whether we'd like to use the current loop or not. This is how we enable and span our 4 to 20. Let's choose yes. Next, we're asked if we want our measured option to be an absolute value or signed, meaning whether we want to show flow as a negative if it's flowing in the opposite direction we think we're flowing. This option is entirely preference, but I'm going to choose absolute. This way I don't have to span my 4 to 20 from negative max flow to positive max flow. This will ultimately give us better resolution for our output. Depending on how you'd like to span your 4 to 20, we could put in our lowest expected flow rate, usually 0, and hit enter. And here we can put in our max expected flow rate, plus probably about 20 to 25% headroom, so we know we won't max out our readings. And the last two options we have are to test our output. I'm going to choose no for now. And to enter a value for error delay. This will determine how long your meter will wait before sending out an error signal to your PLC. Before, in special functions, we specify the value for our error signal. This is how long the meter will wait in an error condition, such as an empty pipe, or very high solids or entrained gas before giving you an error. I'm going to choose 10 seconds, but good values for this are entirely determined by you. My preference is to probably stay between 10 and 30 seconds in general. Now that we're fully through the output options menu, we're done.
Today we covered the basics of how to configure an ADM 7X07 energy meter. We talked about how our temperature probes were installed, how our menu system is laid out, and how to navigate through it. We talked about how to tell the meter what type of fluid and pipe you're measuring on. And then we went into some detail on how to configure process inputs and link temperatures, as well as how to set up outputs like a 4 to 20. After that, we went through the process of actually starting a measurement. And lastly, we talked about how to tell the meter what you'd like to see on the screen while you're measuring, and how to change default values for other functions. Thank you for spending some time with us today. All of us here at Flexim look forward to hearing how we can help you achieve all of your measurement goals for your facility.